In the next few videos, we're going to learn about the built-in modules in Node.js. Among them, in this video and the next one, we will look at fs and path, used for handling files and directories. There are some differences between using them in CommonJS and ES module. In this video, we will check how these modules are used in CommonJS, and in the next video, we will see how they change when used in ES module. Let's open the project we're going to work on. First, I will create a text file like this. The content doesn't matter. We will read the code written in this document with the fs module, and also create a document named index.js and write the code like this. Please take a moment to look at the code. As these examples use CommonJS, we bring the modules using the require function in this way. Even if there is no file named fs in the project, it can be called because it is a built-in module provided by default in Node.js. We will use the readFile function of this module to read the data of the hello document. The first argument is the path of the file to read in a string. Next, specify the format to use to read the data. We will use UTF-8 like this. Finally, a callback function that will be executed depending on the read result is added as the last argument. In case of an error such as the file is not present, print the error object and end the function. If no error occurs, it will print the read data. Since the name of the document to execute is index.js without any specific setting, entering only no daemon, like this will run the code of the document. So when we press enter, we can see that the text of the read file is successfully printed like this. Through the fact that the code at the bottom line is printed first, we can know that the reading operation above was performed asynchronously. For tasks that are small in file size and carry no load, it would be fine to load them synchronously. In that case, you just use the readFileSync function instead of readFile. The code becomes simpler because you're not using callback functions. Because it's a synchronous operation, you can see the result being output in the order of the code. However, as the tasks become heavier, synchronous methods may impair performance, so it's advisable to avoid them. Next is the reverse operation, writing to a file. There are also synchronous and asynchronous methods for writing. The ones with sync are synchronous operations. When you execute the writeFileSync function with the path to the file to be created and the data to be stored there as arguments, a file is created synchronously. We will write a text file named outAsync. For tasks that will be processed asynchronously, a file named outsync is created first, and the subsequent steps are conducted through a callback function. When you run the code, you can see new files being created like this, and the text you input as the argument is stored. If the same file already exists, it will be overwritten with the new one. The code that outputs logs to the console is for comparing the order in which synchronous and asynchronous tasks are completed. You can see that synchronous tasks are outputted before the last line, while asynchronous tasks are outputted after the last line. I will not mention this part in future examples. This time we're discussing functions for appending data to files. You simply need to replace write with append in the function name. The format of the parameters following it remains the same. If you run the code, you can see text has been added to the existing data, as shown on the right. This is how you can add data to an existing file. Since no daemon is running, if you modify the code and save it again, you can see the text is appended once more. Now, let's move on to a function that checks if a specific file exists. For synchronous operations, the existSync function is used. You can infer from its use in the if statement that this function returns Boolean values based on whether the file exists. For asynchronous tasks, the access function is used instead of exists. While there is a function called exists, it's a function that doesn't sufficiently prepare for errors, so it has now been deprecated. So these days, the access function is mainly used to check the existence of a file. This function is originally used to check if a specific permission exists on a file or directory. If you put this constant as the second argument, it only checks the existence of the file and throws an error if the file does not exist. Since all the files with the names putted as the first arguments exist, you can see the result like this. If you change the names of the files and save them again, this time the result that the file with the corresponding name does not exist appears. In the case of the access function, you can see it utilizes the error object in the callback function to check the existence of the file. Up next is about deleting files. The unlink and unlink sync functions are used for file deletion. The unlink function throws an error when the file of the given name does not exist, is in use, or if you do not have the permission to delete the file. Run this following code by putting these two file names as arguments. You can see that these files are successfully deleted like this. After commenting out the unlink sync part in this state, try running only the unlink function call part again. You can see that an error like this is thrown and that the corresponding error object is printed. Since this unlink sync also causes an error if the file does not exist, you should prevent the program from terminating by putting it in a try statement in the field. So, we've learned about using the FS module in CommonJS. Next, we'll look into features related to paths. These two global variables are only available in CommonJS. You cannot use them in ES module. As the name suggests, this one represents the directory path of the file currently being executed. And the file name, of course, represents the path that includes the file name of the file. In CommonJS, you can get the path information of the executing file through these two global variables. Now, let's learn about a module that provides various functions related to paths. This module is called path. The join function of the path module concatenates the given path fragments and makes them into a single path, like this. Currently, there is no folder called files, but we created the information about this path regardless of its actual existence.
Isn't it just a function that takes strings, puts slashes in the middle, and concatenates them?
Its behavior differs depending on the OS where the code is executed. It puts slashes on Mac or Linux, but it puts backslashes on Windows. Besides, it doesn't simply concatenate strings, but it interprets the relative paths of each fragment and reflects them in the result. Please take a moment to look at the code and the execution result. Since the last path has a relative path, meaning the outer folder, you can see that utils is not included in the path. If you put the dir name, global variable, as the first argument, you can create a full path like below. The next function is resolve. It concatenates the given path to the working directory to create an absolute path.
So, is it the same if I put dname as an argument to join and execute resolve?
It's not exactly the same. I will move to the outer folder of the folder where the executed document is and give a command like this. As you can see, the path has changed. Understand that dir name refers to the location of the executed document, and the resolve function of path refers to the location where the process was executed. The following are functions that interpret such a path and return partial information. Firstly, a full path has been generated using a join function like this, and we are going to extract 3 pieces of information using these functions. As you can see, these functions all take a string as an argument. In other words, they simply handle this string as a path for interpretation, regardless of the existence of actual files or folders. Base name extracts and returns the name of a file or folder located at the end of the path. Dir name extracts and returns the path of the directory itself, and xname extracts and returns the file's extension. With these functions, you can conveniently handle path information without complex string operations. Next up are the parse and format functions. As in the previous example, a full path like this has been generated using the join function. The parse function returns an object containing the information of that path based on this string. You can see the information such as root, directory, extension, and so on are divided and contained in different items. The format function has the opposite function. If you put this parse function created object into the format function as an argument, it combines this into a string of the corresponding path to return it. When you need to handle the path as an object, you can use these two functions effectively. Lastly, there's a function that represents the relationships between two paths. We have strings representing 2 independent paths. Please pause the video momentarily and inspect these paths. If you place the paths of these materials into a function called relative from path and execute it, it will show you how to get from the first path's file to the second path as follows. An important thing to note in the field would be that in order to use this function, both paths need to be on the same drive and should start from the same base point. Like this, we tried using the FS module and the path module in CommonJS mode. In the next video, we will explore how these are used in ES module, and we'll take a look at additional functionalities and examples of utilizing these two modules together.